Yeah, go ahead.
Okay. Welcome. Glad to see there's a few people here tonight to hear our presentation. And this is Mary Milroy. She's going to be talking about how to have healthy soil.
Yep.
And you've been here before, but this is sponsored by the Missouri Valley Master Gardeners and the Yankton Public Library. And next Tuesday night is our Missouri Valley Master Gardeners spring, swing. And it's at the Hillcrest Country Club at 7 o'clock. The topic is going to be on you can grow roses in South Dakota. So one of our master gardeners is also a rosarian. And so she's really an expert on everything related to roses.
She knows. Yeah, she knows a lot about roses. So anyway, thank you for coming on this beautiful night. It's nice to have some people show up because, you know, it gets to be this time of year and you just kind of never know how long it's going to last. So thank you, especially to come to a talk about soil science. And so I think a lot of times when yeah, that's the one I was thinking about. Thank you. Yeah, thanks. Anyway, a lot of times when we think about gardening, we start thinking about flowers and vegetables, and we kind of look at our seed catalogs and we have all these great ideas. And I think a lot of times we just don't really think about the soil. And in reality, the soil is the foundation to our garden. And you wouldn't really think about putting up a house without investigating and looking at the foundation underneath it. And it should be the same with our garden. I guess I do have to say that I'm not a soil scientist. And when Shan first called me after the meeting that I wasn't at, when they came up with the topics for this year, and she called and said, would you give the talk on soil science? And kind of she said, first I thought she said, feed your soul, not your plants. And I thought, oh no, I don't know. That didn't sound like my topic. And then later I just, no, it's soil. And I kind of was still thinking that might not be my topic. But anyway, I did think about it and kind of had to say gulp. And I then said I would do it and started doing some reading and actually found it amazingly interesting and also learned a lot that we have to do different next year compared to this year. So it actually was really helpful. And I think the thing about soil is we do kind of ignore it or abuse it sometimes. When in reality, I found this quote that said, essentially all life depends on the soil. There can be no life without soil and no soil without life. They have evolved together. And that's way back from my agriculture handbook in 1938. But I think that's true. If we didn't have good, healthy soil, we couldn't have plants. And if we didn't have plants, there would be no life. There wouldn't be us, there wouldn't be animals, there wouldn't be really anything. So it really is crucially important and makes such a big difference in the success of our gardens. So today we're going to talk about kind of the main objectives today, or we're going to go through some of the soil composition. We'll talk some about soil properties and plant nutrition, and then go on and talk about improving soil properties to really improve the health of your soil. I think number one that's really important is we should all get to know our soil. Lots of soils are different. In fact, in one of these books I read, South Dakota has something like 800 different kinds of soil. And so much of how our plants do is impacted by the kind of soil that we have. So it is important to know your soil in your garden. And remember, soil is the foundation, and that soil quality will either enhance or restrict the health and growability of your plants. And quality soil, not only that, can reduce a lot of your garden work. So if you have good, healthy soil and good, healthy plants, you can do less watering, you'll have less disease, less pest problems, and less need for fertilizers. So all around kind of a good thing. I think one thing to look at is soil is not dirt. I think a lot of times we kind of use soil and dirt interchangeably. And dirt is really just ground matter. It's biologically inert, dead, and provides few beneficial nutrients. And so I thought for kind of an example, this is a picture of my dog. And when she goes out and digs in the soil, she comes into the house with dirt. So, and the other part about it too is soil is not dirt. The soil, on the other hand, is really the living, breathing. It's a complex underworld that's right under our feet. You know, I think we're not even aware of the amazing, complicated ecosystem that's right underneath our feet. When we get to talk about soil, it's made up of about half of it is solid, about half is pore space. So I think sometimes we don't even think that about half of the soil that we look at is sort of empty space. And yet that empty space is really critical to the health of our soil. The solid component, probably about 95%, is made of its mineral component, and about 5% then of organic matter. In the pore spaces, they make up about half of our soil, and it's usually filled with either gases or water. And that can kind of range almost from 0 to 100%, depending on how dry or how wet your soil is. Ideally, what you would like is having about 50-50 for a good, healthy soil. When we talk soil properties, we mainly talk about three categories. That would be the kind of our physical properties, our biological properties, and our chemical properties. When we first talk soil properties, that are our physical ones, what we're mainly talking about is the soil textural class. We're talking about the minerals that exist in your soil. And kind of the basic, kind of dividing it up into three basic categories. Usually we have sand, silt, and clay. And if they're all kind of in a pretty even mixture in your soil, you have what's called loam, which is probably the best and most fertile, easiest to work with soil. And so the soil textural class, you look at the sizes of the minerals that are actually in your soil. And when we look at them, to us, they all kind of look pretty small. But if you look at them in comparison to each other, there's huge differences in their size. And so if we would take a sand particle and compare it to about a 100-foot tall kind of grain elevator, and then we put a silt particle next to it, that could be compared to about a 12-inch basketball. That's kind of the size difference between those. And from silt down to clay, it goes from our basketball down to about a 1-inch stamp. So we think they're all small, but when you're microscopic and you look at them, there's actually really big differences between the particles. And that affects so many of the characteristics of the soil we deal with. When we have big particles like sand, what it does is these big chunks go ahead and make big pores. And it's kind of like putting big rocks in a jar versus little tiny rocks or sand in little tiny ones in a jar. In the big rocks, you have big spaces between them, and it's exactly the same thing happens in our soil. So in much more of a coarser kind of soil, we have big spaces. And so kind of there's good and bad to that. The good to that is that we have really good drainage. That doesn't usually get to be waterlogged. We don't see a lot of root rot. But on the other hand, a lot of things run through it very quickly and tends to leach a lot of the nutrients. So it tends to be less nutritious soil for our plants. If we look at silt, that one's kind of in the middle, has more medium-sized pores. And so it's kind of in the middle as far as kind of the water draining and the nutrient retention. When we look at clay, on the other hand, which we have a lot of clay around in this area, we have much more really tiny particles, very tiny pore spaces. And so what will happen is water doesn't drain very easily. That clay soil tends to hold a lot of water. And so it's easy for it to get like oversaturated. But the other good part about it though is that it actually is usually very nutrient rich. It's not so easy for things to leach out. There's a couple ways that you can do to kind of figure out what kind of soil you have. The first one's kind of a particle size called a quick squeeze test. And what you do with that is you just go out into your garden and kind of get a ball of sort of moist soil in your hand. And then you kind of squeeze it between your thumb and your index finger. Give it a good squeeze. And if it just feels real gritty, you can actually kind of see particles, and it doesn't make any kind of a rope, you probably have pretty sandy soil. If you do that, and you have maybe kind of a weak rope that kind of breaks and doesn't hold together, you probably are more in the silt. And if you're able to squeeze it and a real nice rope comes out, almost like you were working in art class with making a pottery, then you're more likely to have kind of clay soil. And so the sand really feels gritty, and you don't make any of these ribbons or ropes. The silt, they make kind of weak ones, and this clay often will be kind of shiny and sticky and maybe look a little bit more like what you might have used in art class. Another test that's kind of a fun one to do is something called the jar test. And the way you do that is you go ahead and take just a clear glass jar and fill it maybe about a third of the way with soil. And then you fill it the rest of the way, leave a little gap at the top with just some clean water, put your lid on, give it a real good shake, and put it down. And you should have a watch and have a ruler and a marker with you. And then you time out 1 minute, and the first layer will have formed. Put a mark on the glass jar where that was. And then wait 2 hours, you'll have a second layer form. Mark that layer, and then wait 48 hours, and then mark the top of the layers. There'll be just a little water on top, but you'll mark the top layer, the top of the top layer. And then what you can do after that is go ahead and take your ruler and find out how tall the whole column is, and then measure each of the individual pieces, and you'll be able to figure out percents. And then you know what percent of your soil, say, oh my, 20% sand or 40% silt, and you'll have a pretty good idea of what kind of mixture you have. It's pretty rare to find just a pure one, so you're probably going to have a mixture, and this will give you an idea. And the way you could do this is called the soil textural triangle, and you can put those percents in and actually figure out what kind of soil you have. So you can follow these lines, and you can say, okay, my sand percent is, and you could say 50%. And then you can follow that line up, or you could say, gosh, my clay is 20%. And where those lines come, it'll give you an idea of what kind of soil you have. And so what you're going to have is kind of clayish soils here, sandy soils over here, kind of silty soils over here. And sort of in the middle is where you hit that really nice kind of loam. So you'd love to have yours fall in that center of the triangle. Probably the most accurate way to really figure out what's going on in your soil is to go ahead and get a commercial soil test from a laboratory. And they're really pretty easy to get, and they're not really very expensive. And that is probably the ideal way to get a true picture of your garden. And so what you can do with that, I have a slide that talks more about how you get it, but you can send those samples in to the lab, and then they will give you a very complete analysis. And they will tell you exactly what kind of texture you have. They'll give you your pH, what percent of organic material you have. They'll give you something called salt-affected soil. They'll give you the nutrient status, so you'll know levels of, say, nitrogen, phosphorus, potassium, and even some of your micronutrients. They'll print all that out. You'll know exactly where you're at. And even better than that, the lab will then follow up with some recommendations based on, on your findings, what they recommend that you might do to kind of improve the soil. So they often do some very, very helpful recommendations. They also give you what's called the cation exchange capacity, which is kind of an overall measure of really the fertility of your soil. And I have kind of a slide that explains more of that later too. In South Dakota, they used to do some soil testing at SDSU, but they have discontinued that. And so in the Master Gardener course, they gave us this paper that had some of the options of soil testing labs that you can contact and then go ahead and send a sample to. And they will go ahead and give you that. There are also a lot of kind of home tests that you can buy. So if you go over to a garden center or a Walmart or different places, you'll probably find a lot of these guys. And they may give you some rough estimates, but pretty much everywhere where I read, kind of again, stated over and over with kind of a warning that there's a lot of variability from test to test, and they usually aren't really that reliable. And sometimes they're kind of expensive. So really the kind of the better thought was, if you really want a good scientific analysis, spend your money at a real lab. And these are usually at universities, and they will give you a much more accurate one. And the thing too about soil tests is it isn't just one and done. You know, soil will kind of evolve and change over time. So in many times they do recommend that you check it more than once, so that you know, you can check oftentimes in the fall or the spring are probably the best times, and but you want to be consistent. So if this year you check it in the fall, if you're going to repeat it another year or two or three, do it at this approximately the same time. So if you're doing it early September, do it early September, you know, that kind of thing. So you're not doing it early September, late May, you know, like that. You're going to get kind of mixed results. And a lot of times they really suggest that you do it about every 1 to 3 years. And if you're really following your nitrogen, you might want to do it every year, because nitrogen leaching will be probably the most changeable in your garden. So you might want to follow that one. Texture, you probably only need to do once, because then you sort of have the snapshot of your garden. Some of the other ones you might only need to do every 2 or 3 years. I think sometimes they recommend pH every 2 years. But anyway, so that's kind of and also if you have done any amendments or changes, really try to make sure that that has had time to decompose before you go ahead and test. You wouldn't want to just put on maybe some fresh compost or some fresh things and then go ahead and do your test. Wait till it's all kind of reached back to more of its normal steady state. You also probably want to check your areas. So you could send in more than one sample. So let's say you're kind of curious about your lawn, or you say, gosh, I got to investigate my garden, or I really have a trouble spot here. You probably don't want to mix them all. What you might want to do is say, I'm going to take some random samples and send in so I get an idea what's going on in my lawn. I'm going to send in a different set of samples in a different container and find out what's going on in my garden. Or I'll say, this is really a problem spot in my yard or my garden. I'm going to test that separately so I get an idea, maybe a little better idea what's wrong with that or what's causing my problems there. Taking a soil sample is actually pretty easy. We actually had a chance to practice with it a little bit in our Master Gardener course. And actually nothing, said it's okay. And we actually got these as part of our course. And so when they talk about, you know, you really can, you just pick your area that you want to test, and you can use a soil probe, a spade, a trowel. This is a kind of a soil probe. And they're kind of nice. It's plastic. They're kind of inexpensive. They're real handy to work with. And the plastic is maybe slightly sharp so that you can put it straight down and get a really nice core. And the nice thing about that is then your cores end up all pretty even and uniform sizes versus using a spade or a trowel or something. And so they're actually pretty handy to work with. And then you want to do different depths. So, and you will pick right through some random distributed spots throughout the area you want to test. And for a garden, your samples are probably going to be, you want them about 6 inches in depth in, pardon me, in existing grass, maybe 3 inches, brand new grass, maybe 6 inches, and for trees and shrubs, about 6 to 12 inches. So you want to sample a little deeper for them. And then what you can do is, like in this picture, you'll go ahead and get your cores and just pick, like a few random spots, just go around. And you probably want to get at least 5, but a lot of times you might get 10, 15, whatever you want to get. Get a good, reasonable representative sample. And then you're going to make sure that you remove the grass. You're going to get rid of like twigs or sticks or roots. So you just have soil. And then you can dump all your cores into a bucket, mix them up real well, and then probably take out about 2 cups. And you can contact where you're going to send your specimen to get the form that you need to fill out, and probably ask them how they like to have that sample. If they just want it in kind of a clear plastic bag, do they want it in a paper bag? Do they have a special thing you want to send it in? So contact the lab to figure out how they want you to get it to them. And then once you just go ahead and send it in to them, and then they'll go ahead and send you back a really helpful report on give you a picture of what's going on in your garden. When we move into the biological properties in your garden, we start talking more about living things. We talk about some of the microfauna and the mesofauna. And the microfauna are really good. They're kind of like the little workhorses of our garden in many ways. They're the decomposers. They have a lot to do with recycling so many of our nutrients. And they tend to make some of the really beneficial root associations. And so in healthy soil forms things called aggregates, so that the soil isn't just loosely falling apart. It actually kind of forms almost like kind of these aggregates. And the more that it does that, it actually gets a really more established soil structure, which is actually very, very good for healthy soil and good for our plants. And the thing that makes it kind of stick together sometimes is that microbial and fungal kind of glue that they put together to keep it all together. The other thing too is the mesofauna are sort of the bigger things. They're things like earthworms and insects and mites and things like that. And they often are really good decomposers also. They also work to improve the soil structure. And one of the really nice things that they do is they tunnel. They kind of tend to tunnel around. And what they do with that is they aerate your soil. And so if you have compacted soil, one of the best things you can do is get a lot of mesoflora in there and go ahead, or mesofauna in there, and go ahead and get lots of worms and things going in there, because they're going to start tunneling in that and vastly improving some of that compaction problem. The other thing they do that is really great, they just do all kinds of stuff. They eat a lot of debris and kind of organic debris, and then they make worm poop. And worm poop is actually worm castings and is super nutritious. And so not only are they making these nice aerations and these tunnels, they're also fertilizing your soil for you, so you don't have to do it. They make very rich, wonderful fertilizer. So they really are also little workhorses working away under our feet. When we talk chemical problems, now that's properties and things, what we talk about is a healthy soil. We know that our plants need these nutrients to be thriving and strong. And they do need to have oftentimes high levels of nutrients, and they need them really when they need them, so on demand, and they probably need them throughout the growing season. So it's really important to have the right quantity and availability of these nutrients for the plants to do very well. And the soil organic material also can play kind of a big part in how the chemical properties of your soil work. And part of that is that the mineral content of your soil is really pretty negatively charged. So if we kind of think about magnets, what happens when we have sort of a negative pole and a negative pole, and you try to bring them together, they repel. If you have your magnets and you have a negative pole and a positive pole and you bring them together, oh, they really attract and like each other. Well, that exact same thing happens in your soil. Your kind of some of the roots, which are part of the organic matter, and a lot of the minerals have a very negative charge. And most of the essential, really healthy nutrients that our plants need, if we look at things like calcium, we look at magnesium, we look at sodium, so many of those have positive charges. So you'll have like a sodium plus, you'll have calcium plus plus, stuff like that. And so if they're in our soil and we have some good negative charge in our soil, those nutrients are going to say, wow, hey, I'm attracted, and kind of go and stay around the roots and different places. And they're not going to fall out and leach out of our soil so easily. And so the healthier our soil, the more it's going to hang on to some of these things. And that actually gets to be what's called the cation exchange capacity and how well our soil can hang on to that. There are certain nutrients, particularly the nitrogen sulfate, that has a negative charge. And so that one, when that nutrient is sitting there and you have kind of negative charges in your organic material and your roots, that's the one that tends to leach more quickly than any of the other nutrients. So the nitrogen level is the one that we probably have to watch the most closely to make sure our soil isn't getting nitrogen depleted. When some of these, let's see if we can go on, there we are. When we go a little farther into that, then we kind of look at some of this fibrous material, and you can see we've got all these elements in our soil and a lot of our cations, anions in there. And a lot of times it is the organic material that actually will do such a good job attracting these. So one of the best things that we can do is kind of consistently add organic material to our soil as a way of improving its richness and kind of improving that availability of nutrients to our plants. pH is something that also, we can actually measure the pH of our soil. And one of the things that that does is it will very much affect some of the availability of nutrients. Some plants can grow in a pretty wide range of pHs. Some are very specific about where they can grow. But the other part about that is that certain nutrients are taken up better at certain pHs. And one of the things about living here is that we used to be a big inland ocean right here, as unusual as that sounds. And so really a lot of what we're working with is kind of the result of kind of this seabed. And so it's in kind of mid and eastern South Dakota, we have much more alkaline soil because we have the kind of the sea there. And so a lot of times we're not dealing so much with acid soil. And for us, sometimes we're dealing with much more and sometimes too alkaline of a soil. And that's really only a problem if you're wanting to grow blueberries, which really like acid soil, or you're trying to get gorgeous blue hydrangeas and they really like acid soil. So if you're living in Minnesota, you look and see these gorgeous hydrangeas and you say, gosh, why can't I do that at home? But anyway, blame it on the ocean that used to be here. So, and it's a little difficult to really change drastically the pH of your soil so you would suddenly have a blueberry farm or something like that. So this is the kind of a chart that shows you how different some of the different nutrients can be brought up and used by the plants at different pHs. The one that's probably the most relevant to us is if you look at iron, which is this red one right here, kind of the sweet spot in growing plants. We would kind of like our pH somewhere in about 6.5 to 7.5. That's really kind of a nice, happy range for most plants. But look what happens to iron, especially if we start tipping over into much more alkaline soil, which sometimes we definitely deal with here. It can have a big influence on how well the plant will go ahead and pick up iron. And if we've seen chlorosis from kind of iron deficiency, that's probably one of the more common things around here that we can see. And that's directly related to its pH. So, and this is just a little picture that kind of shows a little more.
What's chlorosis?
Oh, chlorosis is really iron deficiency in the plant and it kind of causes, pardon?
What does it look like?
Kind of yellowing and doesn't look very good. If you look, your kind of plant looks kind of sad and yellow and stuff. But a lot of times you look at the appearance of a plant and deficiency, it's not real accurate. You could say it could be yellowing from many things, but it might make you suspicious about iron, but it wouldn't be definitive that that was iron. So, and when you look, this is just a little image of, this cation exchange capacity is how well the soil can actually attract and then hang on to these positive charged ions, which are our cations. And you can look, these little root hairs, they attract it. And so when the plant needs it, sometimes those little nutrients that they need are just right there at the root hairs. They're really accessible. Plant can grab them real easy. And so it'll do that both at some of the root hairs, which are some of our organic matter, and also in some of the clay particles. So the more consistently we keep roots in the ground and organic material, the better we do at maintaining some of the nutrition and the nutrient availability to our plants. So then when we go on, you can see there's quite a bit of difference in our soils. So with some of the clay soils, we do find that they're very fine textured, and and actually in a soil test, they will give you an actual number for what your CEC is. And so in something like a clay, where it's really tightly hanging on to all those, you might end up with a CEC of 25, you might get 50, and you'd say, wow, that soil is pretty nutrient rich. On the other hand, you might go to a very, very, very sandy soil where a lot has just kind of leached out, hasn't been able to stay in the soil. And you might get numbers as low as 5. And then you'd say, wow, my soil's pretty nutrient deficient. And the way you might improve some of that too is by adding a lot more organic material. So, and then that'll keep hanging on to the positively charged kind of particles much better. When we look at some of the nutrients that the plants actually need, there are 17 essential nutrients. And soil testing can tell you exactly what's in your yard. It'll kind of print out exactly what you've got. And 3 of them are from water and air, and 14 they have to get from the soil. So, and the availability of plants do well when they can get access to all these nutrients. And plants do need to be able to access them from the soil when they need them. And they can be taken up at different amounts. But if you're finding that your plants really don't look good, or say you got a lot of yellowing, sometimes what you can do is you can evaluate to find out, is it iron, or what nutrient is it, or what's the problem here? You could do some lab soil testing. Sometimes they'll even do plant tissue testing. You can go and actually investigate what's going on in that plant. And sometimes the deficiency symptoms like drooping or yellowing or spotting or whatever you see oftentimes are not quite specific enough to make a definitive diagnosis. But if you do see some of these, it seems like some areas are a little more prone to develop deficiency problems. And some deficiencies commonly occur in new garden areas. They'll sometimes appear if you start growing a new vegetable, or if you start experiencing kind of unusual weather conditions will do that. And sometimes if you had an over application of nutrients. And what'll happen sometimes is, sometimes I think if a little is good, more must be better kind of thing. And that in nutrients, that is not true. If you overdo the nutrients, it actually can be quite harmful to plants. One, it takes a lot of energy for them to take up and use. If you say put on some fertilizer and your plant's ailing, it actually stresses it almost more because it takes energy to work with that and take up some of that. And so a lot of times you don't actually make it better, and you can end up with other problems by over supplying things. So I think what happens if you look at your garden and you say, I have a problem area here, it's good to sit down and be a detective and kind of look and say, I wonder what the problem is here. And here's a list of even some possible problems that you might be experiencing. Is it a nutrient retention problem? Have you leached too many nutrients? Do you have a drainage problem? Do you have a soil water retention? Do you have too much water? Do you have too little water? Where's your water situation? Tilth is kind of a word that is kind of hard in some ways to explain because it's sort of the holistic overall description of how healthy your soil is overall. Is that the problem? Is it a pH problem? Have you suddenly gotten very, very alkaline and you're starting to notice problems in your plants? And so overall, if you're looking at, this is sort of the kind of the take home, is if you really want a healthy garden, these are kind of the principles of soil health. And sort of the first one is try to maximize soil cover as much as possible. And so what happens is you really want to not leave your soil bare. And what will happen is by covering that soil, you will decrease kind of the water and wind erosion. Kind of a cover acts like sort of like a blanket or an armor over that soil. And so it will protect it. You'll have less evaporation. You may have less water problems. It also will help regulate temperature so that you can avoid big temperature swings in your soil. It also will reduce compaction, and you don't get that hard baked soil. If you keep a nice cover, it can suppress some of your weed growth. And it also provides a nice habitat for different insects and animals that can be very beneficial. One of the other principles is you try to minimize disturbance as much as you possibly can. And, we talked a lot about soil having structure and aggregates and microfauna and mesofauna and, what's going on in here. And it likes to just be in kind of steady state equilibrium. And so it's healthy when that's going on. The more we interrupt and kind of interfere with that, the harder it is for our soil to be healthy. And so the idea is you kind of want to avoid improper or overgrazing areas. You want to avoid over-fertilizing or over-applying pesticides. And you certainly want to avoid a lot of physical manipulation, which would be things like tilling. Because if you've got this nice structure and your aggregates and you go and turn it all up, it's kind of like that poor soil just went through kind of a earthquake and a tsunami all in one day. So it's really not good for the health. One of the other things you can do is maximize your living roots that exist in the soil. That increases some of your organic matter and really increases a lot of the carbon that's available in your soil. You really like to maximize diversity in your soil and try to practice planting different crops, crop rotation. One of the things that we can use to go ahead and cover that soil is to do something called cover crops. And cover crops really fulfill two of the main principles. It really keeps your soil covered and it maximizes living roots inside your soil all the time. And so the way you can do that is you can plant kind of an easy, quick growing annual crop, and you can put it into the garden. A lot of times you can go ahead and, bring it in maybe in the fall so that, you're harvesting and you put in that cover. And then in the spring, when that starts to come up, you can go ahead and kind of work it into the soil before it really flowers or starts making seeds. And then you can kind of just rotate it in to the soil, which provides really excellent organic material and has protected your soil from, wind and water erosion. Some of the more common, yeah.
Does it have to be a living cover? I mean, like you put down.
Oh, you could use mulch too, yeah. And so that is, and actually, yes, you can also mulch. And mulch is more putting a cover over there, and that can be organic or inorganic. So you could do things like wood chips or grass, and that would work. So it doesn't absolutely have to be living. But if you want to go to the second part of that, where you try to keep living roots in the soil as much as you can, then growing the cover crop is going to probably fulfill both of those. Whereas really the mulch will do, probably a pretty good job of covering, which is great, but it doesn't put living roots in your soil. So it's probably good. It's certainly better than bare soil. And then some of the common cover crops that are used are things such as like clover and beans, peas, vetch oats, buckwheat, some of those. And sometimes it'll depend on what your specific problem is, what cover crop you might do. So let's say you recognize that your garden is low on nitrogen, or that you leach nitrogen easily. You might pick a cover crop that would be something that would be a nitrogen fixer. So maybe you'd want to put beans or peas in as your cover crop. On the other hand, if you're wrestling, say, with compaction as a problem in your garden, some things like maybe barley or oats might actually be better in kind of improving your compaction situation. And when we talk about minimizing disturbances, we're really probably aiming at tilling. And I think for a lot of us, tilling was just part of the garden. It's just, I know I saw my grandfather do it, and it just happened every spring. And but the more you read about it, tilling really takes that whole top layer and flips over the whole top layer of the soil. So it's really very disruptive to the architecture of the soil. It does do some kind of good things. I mean, I could see why it was used for a long time. It kind of removes a lot of the plant material, which makes it much easier to plant a lot of times. It does aerate the soil, gets rid of some of your weeds. And so I could see why it was really popular for a really long time. But it is truly destructive to the soil. And a soil that has been tilled and tilled and tilled, you can watch its fertility actually decrease. So what happens is it does make the soil more susceptible to erosion. It definitely disrupts a lot of the habitat to some of your microbacteria, your micro and mesofauna, and certainly kills earthworms, and it leads to increased compaction. So there's a lot of options for that. Certainly no-till is the one that often now is recommended. But I know for some people that's sort of a big leap if they've been tilling for a long time. It's hard to kind of jump in. And so there are some other ones where you just do maybe minimal till, or you just do kind of more of a ridge till. One thing that was suggested was maybe just if you're kind of wanting to be a scientist and kind of explore, you can take maybe just a section of your garden and try no-till. Give it a try. See what you think. And with that, it keeps the ground covered. You keep some the roots in the ground, and sometimes you just make a little spot for the plant you want, and kind of watch and see what happens to fertility. Do it in a season or two, and kind of watch and observe what happens in your garden. One of the best things you can do is to incorporate native plants. Coral will like this, but native plants are great. And what they do is the more native plants that you can get in really the more beneficial it'll be. And that's something we haven't in the past really thought about doing a lot of, but we can blend them right in with our vegetables. There aren't a whole ton of native vegetables that we grow, but nobody ever put in concrete that you have to have your vegetables here and say your flowers here, or, this kind of thing. You can blend them. And the real beauty with a lot of the native plants is they have extremely long taproots. They can be 20 feet, they can be really long, and they are designed to be much more drought resistant. When they go into that soil, they actually can maintain a better water balance in your whole soil. So even if they're sitting here and your vegetables are here, it kind of just improves the whole bed. And so it might mean that you have to do less watering, maybe less fertilizing, so it's very beneficial. And some of the other things you can do, you can use them in borders. You can make wildflower gardens, rain gardens, butterfly gardens. There's just lots of very attractive ways that you can make this part of your landscape. One of the other things that's real helpful is companion planting. And this is something, probably the one that's maybe we have heard about, that's probably more popular, is kind of the three sisters. But the idea is that the plants grow and benefit each other. So it's very helpful. So if with the three sisters, we're talking about corn, beans, and squash. And what happens is the corn makes a really nice stalk. Corn is a very heavy nitrogen user. So if you have corn and corn and corn and corn year after year, you are really going to deplete your soil of nitrogen. So you are either going to have to start putting more and more and more fertilizer on, or something's going to happen, because you are going to kind of really run out of nitrogen in your soil. But since we probably don't want to keep putting more and more and more fertilizer on, what we can do is we can start doing more companion planting. And so if we have our nice little corn stalk and we put a nice little bean plant there, the bean kind of likes that structure, gives it something to grow on. It's really nice. And they're nitrogen fixers. So while they're doing that, the corn's using some nitrogen, the beans or peas are putting the nitrogen back into the soil. And then if we plant some squash, the other part about that, that's a little better ground cover. It'll kind of make some nice big leaves. It'll kind of shade the soil. It might keep some weeds out and give the other guys a little better competition. They're not competing so much against some of the weeds, better water retention. And so they're all kind of helping out each other, make them all kind of happy guys there all together. And so that way, a lot of times we do less watering, we do less weeding, we do less fertilizing. So it just makes our garden a little easier, which is a good thing. One of the things too that companion planting is nice, if you really have a small garden or a small space, it really helps you maximize your space, because you get several plants growing closer together that are really helping out each other. So it actually is in many ways really beneficial. And I kind of looked up and, we think about kind of the three sisters come to mind, but there's actually quite a few. If you go on in some of the gardening books, there's quite a few plants that really do like to grow together that make really good companions. And as you increase diversity, one of the good things is crop rotation. You do not want to plant crops from the same family kind of year after year after year after year. And so by rotating, a lot of times you can do things like use a heavy, maybe nitrogen user, and then follow up the next year with maybe a nitrogen fixer. So you kind of keep improving the soil and not depleting the soil. And the important part with that is to know your family, because it isn't just switch to a different plant, it's switch to a different family. So let's say you planted tomatoes, you don't want to plant peppers next year, because that's not going to be rotation. You got to put something in from an entirely different family. One thing that helps a lot with that is creating a garden journal, because a lot of us, like I've been guilty of this, I think, gosh, I had that gorgeous flower 2 years ago that was that beautiful red one. What was the name of that? Where did I get it? Stuff like that. Then I don't remember. But a lot of times it's really helpful as part of you being a scientist, this is kind of like your science journal, to start a garden journal. You can sketch your garden there. You can sketch it from year to year, what you're doing with your garden. You can put pictures of your garden in there. You can list some of the names of the plants so you do know what you planted last year or the year before. You can write down some of the plants that really did well in your garden. You can also write down some of the plants that did not do so good in your garden, that maybe I'll just avoid those in the future. And you can write down some of your bloom times. You can put some of the growing requirements there. You can go ahead and say, when did you start the seeds? When did you do transplants? Where do you get your plants? What were your sources? Did you get them from a nursery? Did you get them from a seed catalog? Where did they come from? What were some of your expenses? And you can write observations. So some people even write every day and just say, it's kind of their daily journal. They kind of jot down what's going on. And it's really fun to read that in about January. But also you can learn a ton about your garden. And you can become very wise. You can say, this plant does really well here. Or I know how many days it is to bloom. And so, it just makes you really smarter about your garden. The other thing too is you can make notes to yourself. You can say, gosh, I divided these perennials here. So now I'm going to make a note of when I need to do them again. So it's not like, oh gosh, did I divide those last year, 2 years ago? And you kind of remind, oh gosh, oops, I guess that's due this year. So kind of helps you. When we get into kind of trying to fix some of the problems that you might have in the garden, the clay mineral quality and the organic matter are probably the two things that really affect your nutrient retention, that good quality of your nutrients. Changing the clay quantity or percent in your garden is really difficult. That's hard to change the texture of your soil. But adding organic material kind of consistently over time is probably the very best way that you can do that. And you truly can change and really markedly it's that consistent application of organic or addition of organic material over time that will improve that cation exchange capacity and make your soil much more fertile. And some of the ways you can do that, you can add some topsoil to your garden. You can add compost is an excellent way to do that. You can do that at any time of the year. You can add peat and cover crops. So a lot of those really do a nice job of that. Improving soil retention, a lot of times by decreasing soil evaporation is probably a nice way to do that. One of the good ways is with mulch. So if you're concerned about soil evaporation, which certainly in a lot of our kind of hot days that we get sometimes in the summer, that can be really helpful to your soil. And kind of the definition of mulch is a protective layer of material that's spread on top of the soil. And mulches can be organic, such as grass clippings, straw, bark chips, and other kind of organic material. Or inorganic materials work well too. You can use stones or brick chips, plastics. You can use some of the landscape fabrics and things like that. The one thing to be careful about, though, is especially some of the inorganic ones, like some of the plastics, they can cover the soil and kind of decrease evaporation. But beware, sometimes they don't allow a lot of rainfall to get in. So sometimes it could be getting actually too dry underneath. Some of the other things too is you can add, if you go to the store, sometimes they'll have these little beads in some of it that will help kind of retain some of the water too. And those are polyacrylamide, and they will absorb water and kind of slowly release it. And when I was preparing the talk, Dan was saying, gosh, that's probably the same stuff that's in kind of our granddaughter's diapers. And so he said, maybe I will save some of that. But I said, in your car, not mine. But anyway, but that is kind of interesting. Maybe some master gardener will write an article on that. Maybe, I don't know. But kind of recycling that, I don't know, we'll see. But some of the other things, raised beds can do a good job with that. Planting in ridges or elevating the soil like hills sometimes will help quite a bit of that too. Sometimes when you have the other problem where you have a drainage problem, plants require adequate moisture, but they can't have too much. If there's too much water in the soil, then the pores fill up and the poor plants actually can drown. So you kind of have to make sure that you have pretty good water going through your soil also. And that is probably more prone to happen in really fine texture soils like some of the clays we have around here. And some of the best ways to improve that are by adding things like sand or perlite to that. And also improving the landscape by elevating things like raised beds will help that too. Soil tilth, we'll get back to that word. And that is kind of just a really overall kind of overarching term that just means the overall condition of the soil. And it includes a lot of factors like the aggregate stability, the moisture content, degree of aeration, drainage, soil bio. So it's kind of like the big picture of what's going on in your soil. So a good tilth means that it has appropriate water holding, favorable aggregates, good drainage, good rooting depth. So, and the way you get to that is by consistently adding organic material and limiting tillage, and I think keeping your soil covered. One of the questions we get a lot of times is, do I need to add fertilizer? And fertilizer is not always bad, but you want to use it when you need it, and so you should have a soil test. You should know what's going on. You know, what one am I missing, and then replace that one. It isn't really a shotgun. That doesn't help your plants all that much, just to say, they're looking a little puny, let me give them some fertilizer. You know, that's not the best option. And so a lot of times you fertilize when the soil needs, when you know it has a deficiency, and then just add the one that it needs. Native plants help the landscape a lot and really decrease your need for fertilizer. And I think overall, kind of with fertilizers, you don't want to just knee-jerk and apply fertilizer, and that really the overuse of fertilizer is very common. In fact, there was a article even that looked at even master gardeners and looking at their gardens and noticed that they were probably overusing fertilizer. So I think it's a really common problem. And the excessive use of fertilizer does cause kind of an overgrowth of the green part, which sometimes actually leads to decreased fruit production because the plant puts all its energy into the leaves. On the other hand, sometimes it can do stunted growth. You can actually get kind of salt buildup in the soil, and even lead to some of the dehydration or kind of burning from too much fertilizer in the soil. And one of the worst parts is the fact that it can have waterway pollution. And that what happens is these nutrients that we don't need, particularly phosphorus, we put it on. What happens to it? It doesn't stay in the soil. It's too much. It's oversaturated. So it goes down into our waterways and causes a lot of problems. In fact, the dead zones are caused by too much nitrogen and phosphorus that lead to dead zones and kill fish and aquatic life. It gets so bad there, they get algae blooms and they have no oxygen and nothing lives. And I've actually found this that said after these algae blooms, and this is all this runoff from the Mississippi River, so the Missouri into the Mississippi down into the Gulf of Mexico. And what they said is the dead zone there now is about 3,000 to 8,000 square miles. Nothing's alive in that part. Nothing. And said that's the size of Massachusetts. I mean, that's like frightening. I mean, when I read stuff like that, that's terrifying. I mean, that water there's nothing alive in that water. So if there's anything as gardeners and soil managers that we can do to decrease that, by all means, I think that's one of our responsibilities. Some of the things too that are problems in other areas, I think in kind of mid and eastern South Dakota, we rarely have too acidic of a soil. But some of the things that if that would come up on your soil test as a problem, you can sometimes add limestone or wood ash to try and ameliorate that. In this area, probably more what we're going to be dealing with is more pH that maybe gets really too high, like significantly over 7.5, where it does start to affect some of the nutrient availability. Some of the things we might try with that are to add elemental sulfur. We can apply iron itself. We can do acid peat, aluminum sulfate, or even some of the ammonium fertilizers as that. And so that's probably the one that we may find a little more often in our really alkaline soil. So I guess in conclusion, wow, we're really right close to time. Anyway, kind of in conclusion, I think as gardeners and responsible gardeners, what I think we need to do is really just get to know our soil. And it's really our responsibility to do what we can to work with our soil to improve the soil and maintain this healthy soil. And really, I think what we will see in our gardens is our plants will really appreciate that work. And they'll reward us with gorgeous produce. They'll be happy plants, and we give them a happy soil, a happy foundation. They'll be really happy plants. And the other thing is just have fun and enjoy. Gardening is fun too. It isn't all soil science, but it is good to be responsible gardeners, and we'll get happy plants and be happy gardeners. So thank you. And thanks. So I wanted to say that some of the resources that I found, because I have to say I did a lot of reading on this, because when Shan said this, I was like, uh-oh. Anyway, this book, Soil Science for Beginners, I would say, was really a fun, readable book. It's not terribly long, and it just explains stuff so well. It was really helpful. So if you want to read kind of a fun book on soil science that really explains a lot of these principles, really helpful. I would say that the SDSU Extension Office has so many publications online. This is kind of the textbook that we use, but it has absolutely a wealth of articles that are available for you to read on the Extension website. I want to say a huge thanks to some of Dr. Jason Clark's. I used a lot of information from some of the notes that he gave some lectures. He has a series of about 5 videos that I think you can probably get from Extension that we watched during the class. Extremely helpful, and he's really explained stuff well. So I have to say I lifted a lot of stuff out of his lecture notes. So anyway, I had to say a thank you to him. There's a number of publications, and they're actually, interestingly enough, this is something that I didn't know till just kind of recently. There's the National Resource Conservation Service. They have an office right here in Yankton. And if you go there, all these materials, I got some, but I don't have enough of everything for everybody. But this one that's the South Dakota Healthy Soils book is just super helpful. And you can just stop by their office and they have plenty, piles of them. You can just have a free one. And the office, if you go across the street from Walmart, and you know how there's a bowling alley there, it's just south of the bowling alley. It's kind of a nondescript little brick building. Just go in, they have a wealth of information there. This is also one I didn't have enough to give for everybody, but it's an outstanding book. It's called Living Landscapes in South Dakota Guide to Native Plantscaping. Excellent, absolute, yeah.
And the brick building says USDA on it.
Yeah, it says USDA on it.
Doesn't say NRCS.
Yeah, it says USDA. And I did have a whole bunch of these, so pretty much everybody, I missed you, you were back at the seed catalog. If you don't have one, I got an extra one for you. And they also said that in October, you can go ahead and fill out kind of a tree request, and they'll get trees, you can get trees. And also they have kind of these tree poles or whatever they are that kind of let light in, but don't let the rabbits in, which is nice. And you can pick up some of those. They have so much resources and information and kind of really helpful things that stop by and look at them. I don't think they get that many visitors, so they're kind of happy to see you, and they have all kinds of amazing information and stuff that's just free for you to have, and they want to help us, so that's great. So very helpful.
Those pamphlets are all available online too.
Yeah, and online too. So yeah, they're very, very easy to get a hold of.
Tell them about our field tour.
And then come and talk about, I'm going to call on you to talk about the field tour.
So we did we started a prescribed burn association this spring, and Dave's helped with it, and Coral's helped with it. And we did a prescribed burn on about 10 acres up by our place. And it's just been phenomenal what it did. The native grasses, the wildflowers, it's just really, really pretty. And the NRCS asked if they could do a field demonstration walk. And it's going to be next Thursday, not this Thursday, but on the 19th of September from 10 o'clock till noon. And there's a range management specialist from the NRCS office in Mitchell named Rodney Voss. And he's expert on native prairies and stuff and pastures. And he's going to come and lead the tour and talk about the use of prescribed burning to help control the cedar trees primarily. That's one of the main reasons we did it. But also promote native grasses and native grassland habitat. And so we're inviting people to next Thursday if they
want
to come. And it's
welcome.
located at 136 Heritage Drive,
Yeah.
about 8 miles west of Yankton. It's about a mile and a half south of the BY water tank and where the Scramblers motorcycle track is out there at the intersection of 50 and 52.
Yeah, because we've lived there probably over about 30 years and we've probably had cedars removed 3 times. And I know Dan has called them kind of the green glacier, but we first moved there, it was really beautiful prairie, and before you knew it, it was just cedars. And you couldn't use it for pasture land at all. It was terrible. And so I think we had them sheared one year, and then maybe 10 years later, we had to have them chipped, and then with a lot of work, they finally got rid of them again this year and then did the burning. And I have actually been absolutely amazed that you go and look at it now, the flowers that are there and all those seeds had to be just sitting there because we didn't plant them. And you go and you look and it's just this, like right now, it's just this landscape of yellow and there's these little purple ones and like they've been there all along. It was just those darn cedars were kind of taken over. And so, but anyway, so I think if anybody's free that day, please come. And I think that the guy knows tons about native prairies and prairie restoration. And so I think it'll be really informative and kind of fun. And we're hoping for really good weather. I don't want it cold and I don't want it 95. So we're putting in our request for good. I had no rain that day. I do want rain, but not that day. So anyway, so thank you so much for coming and I appreciate it. And I will take questions and try to answer if I can. So, anyway, this is a book that I borrowed from Marlis, also an excellent book about pastures and crops, and just say thank you and take questions. So anyway, thanks everybody. So,
I have a question.
yeah, please.
I started to mulch and then the plants that I was hoping would come back every year like they used to, they don't come back.
So I think sometimes when we mulch, you don't maybe always want to totally cover them. You kind of want to leave a little bit of room right around them. I think sometimes too.
Yeah.
But I don't know if I can explain if other people have ideas too.
Well,
But
It's really dependent on the plants.
yeah,
You might have gotten something that was actually short-lived perennial. That
no,
only
these
lasted a
these
little
came
bit.
back
they
every
came back
year.
every year and then not this year.
Interesting.
Yeah, because sometimes it has to do maybe with the weather and we had a horrible winter in terms of kind of temperature fluctuations too, that was hard on a lot of trees where, it'd be really cold and then it'd get really hot and it'd get really cold. And so we had some things that were real hard on some plants and trees. And then mulching, sometimes you don't want it too thick.
And sometimes when people go to the city has mulch available.
Oh,
People sometimes go get mulch from there.
Yeah, that is something you gotta be a little cautious because sometimes you pick up maybe some of the mulch from the city. And some people put their grass clippings there that maybe have a lot of herbicides on them. You gotta be careful because there have been people that have been really burned by that. And with a lot of mulches, I think what I've read too is like, especially like trees or different things like that, you can't bring it right up to them. You need to leave a really nice ring because you can kind of smother some things too. And you don't want your mulch too thick. So those are just guesses.
Well, another thing, my husband always insisted we suck up the grass. Well, finally, last year I took over the yard and we don't suck up the grass anymore.
Okay, good.
We don't water and we have nice lawn.
Yeah.
And I can say, I told you so.
Yeah, it's probably, you're getting more organic material in, which is really good. So your grass is saying thank you. So that's good.
Back to the question about roots and in the garden. Okay, it's fall now, I'm gonna, crops, everything's harvested.
Yeah.
Do you rip out the old tomato plants? Do I rip out all the other stuff? Just,
No.
I can take the tops off, but you wanna leave
Oh, you
those
can
roots
leave
still in
them,
the
you
ground.
can even leave the tops.
I thought people said you get that stuff, it's gonna cause diseases or something in the next spring.
Unless it's already diseased.
If
Unless
your
it's
plants
sick.
are already diseased,
Okay,
then
so
they're already
just-
set top grow.
Yeah.
As we changed from tomatoes, we went to a different crop, and all the tomatoes we ripped out, and I had the feeling we were doing the wrong thing.
Yeah, I think what I've heard is that, like even some of those standing plants that are there, even if they're dead stick kind of things,
Yeah,
sometimes birds will go sit on them, birds will come and maybe eat some of the maybe leftover tomatoes, or it makes more of a habitat. And then you could kind of turn stuff over in the spring. So plus you can kind of even work some of that as long as your plants aren't
Okay,
sick.
because some raccoons came in and ate a bunch of corn we had.
Oh, yeah.
So, okay, but I could still, the root system is all there, and I should leave that.
Yeah, I'd leave it.
Okay.
I'd leave it.
That's what I,
Yeah. The deer came and ate all my eggplants.
they're fussy.
I was really not happy about
I
that.
planted eggplant and I don't like it.
Oh, no, I love eggplant. And I had 4 plants and I had them all there. And now they have these gorgeous big leaves. And we were gone for about a week. And